welcome all of you on the first independent Big Data and High Performance Analytics Forum. It's really an honor and a great pleasure to have all of you here today. My name is Panos Tselos, and I am the organizer of the conference. Firstly, I would like to cordially thank all our great speakers and coordinators for being here today. The majority of them have traveled from far away to contribute to the diversified multinational conference. Mark Madsen from the United States, Andrea Alemeyer Stube from Germany, Konstantinos Tsiptsis from Greece, Rebecca Ali from Lebanon, Atif Rahman Abdul, and Belouari Adil from Saudi Arabia. And last but not least, Victoria Zakowski, Yemivov Dimitri, Muhammad Altaf, and Mohammed Samar from United Arab Emirates. All our speakers with their depth of expertise will enlighten us on many critical issues that already exist in the business analytics industry, and meanwhile will provide their visions and dynamics of BA in their industries. Also, I would like to thank our respected sponsors that contributed with their valuable participation and support to this great event. I would like to name all of them: the sponsor Aliot Hadi Shahid Chartered Accountants, the executive recruitment sponsor for business analytics JobHunterNetwork.com, the telecom solution sponsor Telephony, the smartphones apps sponsor Jupiter. Please feel free to ask our distinguished speakers any questions related to their topics, as we will have enough time after the presentations to discuss further on your concerns. Before starting the panels, I would like to inform you that at the end of the forum at 3 o'clock, we will have a networking reception at Summit. It's outside the space of the auditorium. And as I have already informed through my emails, this is a private, closed event giving to you the opportunity to get together better with the rest of participants of the conference, discuss on more issues, and exchange great ideas. For the beginning, I would like to welcome our keynote speaker, Mr. Amar Ahmed from Saudi Arabia, Executive Director of Sky Computing Consortium. Ahmed is business and technology evangelist, speaker and author with more than 2 decades of experience in project management, ERP, application development, e-healthcare, business alignments, and transformation. He has delivered wealth of projects for the different business domains across the different geographic regions. Mr. Ahmed, can I ask you to come to the podium?
Hello, good morning. I would like to welcome all of you for this wonderful event, and I think this is one of the nice topic we could have in the region, although so many events I have been delivering and I have been attending, but none of them was like on the big data, so thanks to the organizer, Panos, and everyone. So it's my great pleasure and honor to be in front of you. And my session, I will try to make it like more like a thought process. As he has already introduced to me, so I have more than 2 decades of experience. And in these 2 decades of experience, I have been interacting and computing the data in kilobyte, megabyte, gigabyte, and that's all. Now we are listening since a couple of years like something called petabyte, exabyte, zettabyte, yottabyte, and there is something I heard recently, there is a brontobyte and geobyte as well. So all these bytes, it is there because there is one reason for that. Although so many people they call it's like big data, it's like a buzzword, or it is something like just to sell something to the vendors and all of that. So we are actually seeing a trend over here. Each one of you have a smartphone. Each one of you have more than one device which connects and which provides the connectivity. So according to Gartner and according to IDC, they came up last year, October, I believe, like a nexus of forces where we have like four convergence forces, which is cloud, big data, and social technologies and mobility. So these are the four forces we are talking about. When you converge all these four forces, then the value can be driven and the value can be unleashed. According to IDC, they call the same technologies and same forces as the third generation. When we started with the client and server environment, it was like first generation where a client has to connect to the server and so on. So now, according to IDC, again, those four technology they have named as a third generation. So what we see today, not only the computational objects which we see as a smartphones, or you talk about different devices, you have different embedded systems, we have smart TVs and so on. So all these devices and peripherals and instruments, they have a kind of connectivity. So the data is being emitted from all these kind of devices. So my particular role for this particular speech, I will just try to give you an overview. I see like so many speakers, they will be able to explore more depths along with you. So so this is my little bit agenda. However, I will be skipping some of the slides as and when it is required, so that other speakers they can explore those topics. So I would like to start with a quote which is Albert Einstein. Not everything that counts can be counted, and not everything that can be counted counts. So when in terms of the data, it is not about whatever the data it is there, it is bringing the value. So we have to know what we need to drive, what is our business objectives, what are our business goals, what are our strategies, what is our mission, and all of that. So when you talk about the emerging technologies, it is not just about the technology. We as an IT, I'm an IT pro as well. We as an IT, we believe that IT is in the hands of IT. No, the trend has been changed. The IT is no more in the hands of IT. The more IT investment is happening away from the IT. Whether you talk about the different devices which is accessing our network or the infrastructure and so on. However, I will try to tap that particular topic in. And what I am saying here, if maths and science are important, that's what we know. Either it's maths, we are talking about taking the decisions based on the facts, based on the statistics. And science it's a phenomena. You need to understand everything. If they are important, then the science of sense making is critical. So not only we have to have an analytical way of computing the data or driving the value, but also it has to be sense making. It has to be with regards to that particular context. It has to be with regards to that particular situation, from that particular perspective. So we have to cover not only the IT perspective, but also the business perspective. Like we have with the emerging technologies, when you talk about the cloud and so many things, for the CFO, it is about the cost saving. For the IT, it is about consolidating and unifying and aligning and making the service at one central place where the backup, restore, disaster recovery and all of that can happen. So those kind of things are coming together. So it's an opportunity for an IT pro to have a better implementation of IT services which are more business friendly and so on. This is the newspaper recently, last week. I just come across with this. So in this, there are different things are happening. So I'll just try to skip this, and here it is. So here, accurate jobless data of South is a dire need. This was, I think, on 16th of this month. So it is not just about the data, it is about finding an accurate data, finding a data which will make sense to what you're doing today. Whether it's a government entity, whether it's a private sector, or whether even it's a department. So there are new innovations are happening. Apple, they came up. They are working as per the rumors. They are working on iWatch, and that is going to dramatize the whole thing. Even your DNA and your healthcare services, they are trying to put it together so that your blood pressure and everything can be sensed. However, this is not factual, but this is what we have been hearing. Google Glass, Microsoft Glass, they came up with the augmented reality where you can see the physical world and find the relevant information about that particular physical object into the virtual world. So you just don't need to see or go back and leave the virtual world to the physical world and go to the virtual world. So basically, the concept of globalization, the concept of virtualization, the concept of physical world and the virtual world, they are no more an isolated area. Virtual world is coming closer to the physical world. Each and every individual have a stake in your virtual world. Whatever we do it in the virtually, that is reflecting on your physical life, on your professional life. So everything is a part of the same life. So when you are talking about so many marriages are happening by using the physical platform, virtual platform. So there are many things are happening. So there is nothing like a virtual world. There is nothing like physical world. As we have seen in 1980s, when the TCP/IP protocol was developed by the scientists, I don't remember one, but the other person was Bob Hahn. So when they came up, the first challenge for them to have the connectivity between one PC to the other PC, and that's how the internet was built. Internet is nothing but just having a connectivity from one PC to the other PC. And that's how it was scattered, and the domino effect has happened across the different regions, across the globe. Now we see millions and billions of machines. Almost like 30 to 35% of the population is connected to the virtual world. They have the connectivity. And even as per the statistics, for my last month I have studied, Middle East is the region which has the highest percentage of internet connected population. Although the numbers are less, but from the percentage wise they have more penetration. So we are in the transformation world. We are seeing the transformation of the technology, and this transformation of technology, it is not just transforming the technology, it is transforming the human life. Whether you talk about the social services, you talk about the humanitarian services, you talk about education, you talk about government citizen services and so on. So it is impacting every aspect of our life. These are some of the statistics I just try to put it, and they may not be very up to date because that was I built around 4 to 6 months before. But the major thing which I would like to say, that the mobility. Now even we are saying the mobility, it is one of the emerging force. Mobility is integrated. You have to access the data on the mobile devices. You need the data which makes sense, which impacts your personal life at every moment of time. Whether you talk about the leisure, you talk about making a business travel and so on. And the globalization and localization is happening. What I usually say, the globalization, it is shrinking the world. It is bringing the people together. Now we are a citizen of the global community. We are no more citizen of a country, but we are a global citizen. Why? Because it is actually providing those tools, providing those platforms, providing even with the Google translator and with the natural language evolution and with the help of the AI and machine language learning which is happening, this is actually now we are in the at a time where the real globalization will happen. When we talk about the globalization, we think it's about the business. Yes, now whatever I have the services, whatever the portfolio of products I have, now I can sell to the different audience at different geographic locations. But now it is the best time for the vendor to sell. It is the best time for the consumer to consume those services, products. So it is win-win for both of us. Being a neutral speaker, I am not trying to, my focus will be just to create awareness. And one more thing, Middle East is one of the region where you are not just talking about the globalization. Globalization is good, it has to happen, but it should not happen at the cost of the localization. There are local trends, there are local traditions, there are ethics, and so on. Yes, you have to be global, but not at the cost of the localization. This is some of the statistics, how the human mind it is processing a certain amount of the data and all of that. I think that may not be required. According to Cisco, Internet of Things, actually Cisco, I believe they came up maybe 6 or 7 months before I came up with that Internet of Things. However, I was saying about this same thing, but without naming as an Internet of Things. In my next slide, I will talk on that particular thing. So we are talking about ABCD. So when you are talking about, when you talk about the technology, when you talk about the cloud, when you talk about the big data, it is not just about the technology, my friend. It is more about the business agility. It is most about business flexibility. It is more about business benefit. It is not just the technological transformation. So when you are actually when you have an access to the data, you have to see who are my customers. What do I need to take the data? What do I need to take? Not everything. Whether it's you talk about the structured or unstructured or semi-structured, not everything you can take. So you have to know what we have to take and when we have to take and where we have to take and why we have to take all the data. So without going into detail, again it depends on the business. What I may recommend for one business or one solution for a specific project, it may not be relevant to the other project as well. Because the solution it differs, because your context may be different from the other. So same problem will have different prescriptions being a doctor. So we need to anticipate what exactly I want. So it is not just about I just have the data and since it is a big data, last month in London, I met with he was the CTO for the Ministry of Defense for the US. His name is Dennis. He said it's not just about the big, how big it is. No, it is not about the big. It is about the quality. It is about the value. It is big, but for me, I don't want. Maybe I'll be paying more than what it really brings the revenue for me or the value. Those are the things. And when we identify, we need to see how we can accelerate and how this particular data, it will be a differentiating factor for you to bring the value to your business. So these are the three. Without these 3 V's, I think the big data cannot be. So I will just touch those 3 V's. However, I try to rename it. It's about the volume, because these are the challenges. These are the challenges, these are the opportunity. That's what has been, everybody's talking about. But in fact, why we are dealing with these 3 challenges or 3 opportunities? Because to drive the value. So for us, driving the value is the driver from the big data. Why we are saying it's a challenge? The data was there, for some of the big like US, NASA and all of that, they were dealing with the big data. Why we are saying? Because now even the data which is in bulk or which is in huge quantity, which is coming from different sources, from different devices, from different objects, and with the different, even the location services. When I just landed in Dubai, when I switch on my iPhone, I get the recommendations relevant to that particular location. So now for the vendor, the data vendors, it is an opportunity for them to identify those customers who are in need of those services, which is required being a person who is on a move. Those things. So the volume is there, but the traditional computing environment will not allow you to compute the data. We have so many enterprise data warehouse systems in place, and we used to run one report, it used to take 2 to 3 days because of lack of infrastructure or the computational power. As you might have seen previously, big companies, large enterprises, whenever you talk about the big data centers, it used to be like a big premises, a big building, and that building become like a floor now, with the 10 times or maybe 100 times higher computational power. And those floors, who used to be as a floors, now they become like a hall or a room. And the room has a shrink to a shelf or to a cabinet. And this is what. And not only we are shrinking from the physical aspects, but also we are increasing the computational power. So now, since I have the power to compute the data, to make and to bring the value within the real time or as fast as possible, which makes sense or which gives, which helps me to make certain decisions. That's why. So those are the challenges. And according to Gartner, I think by year 2020, the big data will be again renamed as a data. It is not just about why we have been calling it big data, because those are the challenges. And by these coming years, those challenges will be met. We will have the maturity of those computational environment, the techniques what we are using. Even we have Hadoop, Hive, and so many platforms which is used for the big data. But still, the cost of computation is much higher. So we don't have that much. Last week, we have the SAP environment. We would like to do the Unicode, and we want to Arabize our SAP environment. And when we asked the big vendors, they said they started from 15 days, and then they said 1 week, and then the last was 4 days. They said we need 4 days, the system to be down. So, and this is what has been proposed. So what has been talked is not what is being practiced. So still there is a gap, and that gap is getting minimized, and a lot of work is being done, and I hope in the coming days or in the coming future that will be resolved. And velocity, which is the real time. There is nothing important in human life more than the time. In one of my speech I said, time as a service. Some of the vendors, they need to think time as a service. Now what we do, being a project and management practitioner, we see this is the scope of the project, these are the goals, these are the objectives, and whatever it is required in order to achieve that particular goal or in order to achieve that particular objective, we just see what are the resources we have, what are the resources we need to have or we need to bring it from outside, and in what time and what to deliver in terms of expectations. Those things, that's how we do it. And I'm not saying that's the wrong approach, that's how we do it. But there is another dimension. There are certain seasonal services. Now Amazon, they came up with the AWS and all of that. So you pay only for that particular time. So you are paying the cost for the computational power for that particular month or for that particular, like in Saudi Arabia, we have like Hajj season. Lot of data is being computed at that particular time, and lot of data it need to be unified, and you have to make certain decisions and all of that. That is not happening. So time as a service also can be done. Like you decide, I'm going to make a service available as a time for that particular segment. Whatever the resources is required, in that particular time, so will be given. So you are actually charging based on the time. So here, that is not the thing which I have to talk. Here, making the data, computational data, or making the valuable data within that particular time, it is one of the challenge. And if you meet the challenge, that's an opportunity for you to encash. And variety of sources. It is not just about, like what I see, they call sensor data, climatic data. Is it really affecting to every consumer? No. But this is how I have been listening. The other, speaker, they have been talking. Yes, that's good. Now, getting the data from the climatic, so I know what is the forecast and I can prepare myself. But there is a lot of devices at our home, inside our car, which we are sitting. So those things we need to consider here. So I think I'm going to go only with the half of my presentation. However, I think I'm going to cover up some other things. So here I'm trying to bring the rhythm only. I'm not trying to give the more details. Here, in general, as an information officer, information is given. What is the use of information when somebody is not taking action on that? I know that there is an earthquake is happening, and I'm just standing and say, yes, I know it. Earthquake is happening. I know that there is going to be rain. And this is what exactly happening today. We see, he's a chief information officer. Yes, sir, you are, with all respect, you are an information officer. But the role of the information officer is transforming. Not only it's a technological transformation, it is a mindset transformation as well. So you have the new technologies, but the mentality or the mindset is the same traditional. You are thinking about the same way. That is not going to work. Even I saw in several events, they talk about cloud, means they talk about the virtualization. Yes, we have virtualization and a lot of things are happening. Yes, from 50 servers, you may have virtualized to 15 servers or 10 servers. But that's not the cloud. There is a complete life cycle. An alignment has to happen. Identification. If you don't know what is your problem, how you are going to solve that particular problem? It has nothing to do with the technology. So here I was saying the same thing. You talk about the PMI. There is an input, there is a computation is happening, or certain tools and techniques you are applying, and you are getting an output. And that output is meant for certain input. So an information is given for you to take certain actions. When you take an action, that becomes like a knowledge. Knowledge is important. Information is source. Information is like the sea, what you are seeing behind you. It's like a raw water, which is salty. We cannot. You have to make the treatment. Some treatment has to happen so that you can consume as a healthy water. I will not talk about this. So I think there are certain, every budget is an IT budget. And certain statistics, so I talk on this as well. So the data is coming up. As you can see over here, this one, 6 months before I put only this heading. The whole thing is same as it is. Gartner, they came up, they call as a strategic big data as one of the top 10 trends, which is going to happen in the coming 5 years. So basically what you see, we used to call 360 view. No, with all respect, enterprise data warehouse is not 360 view. There is a social element is there. You have to know what is happening, what the customers they are talking in the market about your particular product, about your particular service. Not, I am thinking I am the best. It's not about me. It is about you. It is about others. What you think. This is what it matters. So we have the semantic technologies which understand the natural language. It doesn't have to be the technological language. The technology has to have, the technological guys, they have to talk the business language. I am an IT architect, but I don't talk about the technology. You talk about the business. I know how to use, what to use and how to use and what tools I need to apply and all of that. I think I'm running out of time, so I'll just skip this as well. So here, this was like a delivery model. When you are talking about collecting the data, when you are talking about the collecting data itself is a life cycle. What data you need to collect? You need to identify the data. So in order to identify the data, you need to see what are the sources of data. And what are our objectives? What is our mission? What we are targeting for? And it's not only about the top to down, but also bottom to up approach as well at the enterprise level. So collection of data itself is a process. It's a complete life cycle. When you are talking about the business, you are talking about not only like people, they call people, process, technology, but there is so many other things as well. Social elements, social network services, whatever has been happening. I am selling a particular product, let's say a heater. I am a heater manufacturer. I am selling a heater in the hot condition. That is not relevant. So now the intelligence has to happen not only from the product side, but also from the climatic considerations you have to make. Location services you have to make. What is happening? Maybe the factual, most of the IT guys we used to claim, including myself, we say we are fact-based driven, we are data-centric. Yes, that's good. But also there is sense making. Yes, the fact is that that company was making profit for all the time. But now there is a natural tsunami has happened. Sense making, it doesn't allow. Yes, it was a. So that's how you have to, this is how you have to pursue. It is not about how you look at the things, but you have to consider others' perspectives as well. Customer's perspective, your employee's perspective, your business perspective, your strategies, and the context and the situation where you are in. So when you collect and you process the data, you compute the data, the computational power, it is in the flops. Most of the IT guys, including myself, I studied during my engineering, that's a flop. This is how you measure the processing power for any machine. And now the supercomputers are being evolved. And you manage the data and you measure the data against your metrics and against all of that, and then you consume. I'm running out of time. So, and then you store. So even storing data is not just a store, it's not just a copy and paste. There is a lot of structure. You need to understand what is the data structure you have, what are the data sets you have, what are the meta tags, how you should define, so that it will make sense, it will be searchable, and so on. And then you'll be able to transform, and then you corporatize, means that data is available for you, for your consumption. And this is a governance process. This is a governance. The life cycle did not stop here. This is a complete. It keep on moving. So again you will be collecting maybe what you considered in the initial cycle, that after having been through the cycle, you think no, there is some other data we need to collect, and so on. I think I just talked on this particular thing. So the counter is running up. So these are that's what I actually am supposed to talk, but I think this is what you see. So these are some of the slides which I put it, so for you to be aware, and for those who may not have seen everything, time to market. So now the old saying, cheaper, faster and better, which is not possible in the reality of life, but this is it is happening to some extent. And the technology is really empowering all the rural areas in India and some other countries. Urban areas, of course, they are the people who have a lot of money and technology and all of that. But the rural areas now, the technology is going to them, and the healthcare sector is one of the major sector, and the education sector, and the citizen services also can be delivered. Social technologies. So I will take 1 minute over here. I was just talking about that. It is about, now according to Gartner, I believe, the role CDO, Chief Digital Officer, by 2015, I think, yes. operating CDO is a chief digital officer. He is an executive with the operational experience and management skills and strategic mindset and vision to lead and all of that. And 25% of the large enterprises, of course, in US, that's by default because that's the statistics. It comes from that. So and his role to digitize the business. So the digitization, it is the major and mega trend which is happening to transform, and all of that is happening. So the CIO is also the chief cost-cutting officer as well, which we see in this part of the world. And thanks a lot, and thank you. I think I'm out of the time.
Next speaker is Mark Madsen. Mark has spent the past 2 decades working on analysis and decision support projects in many industries. He's the founder of Third Nature, a research and consulting firm focused on emerging technology and practices in analytics, BI, and information management. Mark is also an award-winning former CTO and consultant who frequently speaks at US and European conferences. Mark, I would like to ask you to come to the panel.
Good morning. Thank you, everybody, for having me here. It's a great honor. I traveled 9,816 miles for this event, so I really wanted to be here. I'm going to talk about big data and decision making and some things like that. Now, my background is sort of unusual. Apart from having an engineering background, I was a botanist for a while. And I studied behavioral economics and cognitive psychology. So a lot of times I came to things from a different perspective. Rather than being a technology person, I was a decision person. And I fell into business intelligence back in the early 1990s, late 1980s, the first time around. And it was very interesting because it was all driven out of business. And it got very technical and technology driven. And now we're in this big data cycle, and everybody talks about big data. And it's very often driven from a technology perspective. And we heard reference to that just a few moments ago. But what is interesting is the underlying factor is a technology development, and it is simply the commodity pressures and development of computing technology. Ray Kurzweil, a long time ago, plotted out various genres of technology from the electromechanical to silicon computing, and transistors, integrated circuits, now massive integrated circuits. And this is a logarithmic chart. So what we're seeing is, each line is a factor of 10 improvement. Now, when we started to apply modern, I would call modern, business intelligence and analytics in the 1980s, from that period to today, we had a 10,000-fold improvement in processing and storage and things like that. Now that's a tremendous improvement. If you think about the car and the mileage we get out of a car today, a 10,000-fold improvement over a 25-year period would mean that your car could drive, 500,000 to 5 million, depending on the car, miles on 1 gallon of gas. Now that's a tremendous change. Now, interestingly enough, in 1957, Ford Motor and General Motors were looking at various cars. Now, this is the Nucleon. It came up in 1957, and it could actually get 1 million miles to the charge in their prototype. The reason it could get 1 million miles is because it was an electric car. And the way it was powered was this nuclear reactor in the trunk, which has a few drawbacks. Now, the problem was that they looked at technology and they extrapolated based purely on technology without thinking about pragmatic concepts of how one applies technology to a problem. and the fact that after driving about 10 miles, you'd be sterilized to not have any children, and their customer base would disappear. So obviously this car never came to market. But if we look at business intelligence, it's really about applications to business problems, and the technology for business intelligence, the kinds of things you buy from SAP and IBM today, and the capabilities that it delivers, they've been around for 25 years. Actually, this year is the birth date of the term data warehouse. It was coined in 1988 in an academic paper published by a couple of researchers at IBM. And we've reached the point where business intelligence, the tools and the things that are offered are a commodity. They don't have commodity prices. The average in the US for the major BI vendors, MicroStrategy, IBM Cognos, Oracle Business Intelligence, and SAP Business Objects, is on the order of $1,500 to $2,000 per seat, which is definitely not commodity pricing. Interestingly enough, Microsoft Technologies all-in come in at right around the same level. But from a business perspective, it's a pure commodity. If you don't do this in most businesses, and at least do a passable job, you don't function. It's become a cost of doing business as opposed to a differentiator. Now, when I started out doing this in 1989, 1990, very few companies really had much infrastructure, and so it was a differentiator. And that shift from commodity, or from unique differentiating technology to a commodity cost of doing business, is just the nature of technology development. And when you look at data warehousing, we had a few principles. One of them was get the important financial data, put it into a data warehouse, store it, and then get fact-based access to it. And they labeled this the Enterprise Data Warehouse, the EDW, and people pushed that for close to 25 years. The problem is that all the consultants that we had told us the E meant everything. All the information would be in the data warehouse or in our business intelligence system and form the business. The reality is that we were very careful about choosing only valuable data and choosing the data that was common to every part of the organization. And also in a period of data scarcity, we had really limited automated data like financial transactions and ledgers, payables, receivables. And so this was convenient data. Now the interesting thing is from a solving business problems perspective, most of us historically did not start with a business program and decide what metrics are important to measure the program in terms of its success. Like our success is we'll make $10 million on this new product launch next year with a margin of 14%. But from those outcome metrics, which usually are financial and can come out of the data warehouse, there are the process metrics to tell you how to track that business program. To say, well, this is the goal, we'll start the program here, but in order to course correct and to know whether we're making success against the outcome metrics, we need other metrics. And those metrics are going to tell us things about the input, about the process, and very seldom did we build those into the business processes or the applications that go with the business programs. I've done a lot of things with suppliers and demand chain planning and things like this across multiple organizations. And in every case, somebody was not collecting important data, only the convenient transactional data. The inconvenient things are inconvenient because of things like volume. The first big set of high volume customer data came off of websites and web analytics and web transactions. And it was never really designed into systems for analysis. But it was there, and what you're really talking about is observing. It's observational data. It's not transaction, but it's the things that happen before and after and during the transaction. And so there's a finer granularity of information, but it's noisier and it's messier. And then the really difficult things are the things that we deal with in the marketing organization. Customer surveys, customer sentiment, calculating or attempting to measure things like brand value. And brand value is often sort of talked about as a not really concrete thing, but you look at some organizations like Coke, who came out with New Coke and almost destroyed their brand value overnight. And those sorts of things are difficult because they're declarative. They're what people talk about and what people say. And the problem with declarative data, if you deal in market surveys or market perception or competitive intelligence scenarios, people say one thing, but they behave in a different way. And so you need to be able to make use of all three of these things so that when people say one thing, you're actually observing that they're doing things that they say, or that you're able to see that what they say diverges from how they act. And you can also see whether or not there's any financial implications to their behaviors and what they say. Because there are a lot of customer satisfaction surveys. Airline industry surveys are a great example, where people say they're unsatisfied with this airline and it's the bottom of the heap, and yet it's the most profitable airline, or it's the largest airline. And so you have to tie these different classes of data. And one of the things about the big data revolution is that it's really about these things. This is all what we've been doing for 25 years. And so that's where the new values are coming from. Now, along with that are things like sensor data. Now, sensor data doesn't just mean sensors, environmental sensors or web servers, but it's also things, as we heard earlier, like your phone. And your phone is not really your phone. If you've ever looked at an iPhone or another smartphone, the phone is an app. There's a little application for phone along with all of the other applications. Now, every single one of these can be and usually is instrumented. There have been a number of privacy problems with Apple because it turns out that any application could access your location data and your contacts and your email and your notes and your calendar. And actually your calendar, your notes, and your contacts are still accessible by most applications on an iPhone. And some of the less privacy-worried vendors of apps have actually pulled that stuff in, and they store it on their servers. Now, where it is legitimate, though, is when you have a business application, and a lot of us are starting to deploy mobile applications to our workforces. You can see how it's being used, the context where you can actually map the location to a customer's office to see that the salespeople are at these locations. It's all very interesting, and it's sensor data. Sensor data is not a transaction. It's a continuous stream of events, location pings, or accesses to applications, or things that I've done in the medical field, looking at hospitals and the expensive equipment nurses take to patients' rooms. In one case, we attached a sensor to each piece of equipment and measured it for 60 days, and then we had a map of the hospital drawn up, and we could see the paths, machines taken from one place to another. And when you see excessive movement of machines, you might need more. You might have better ways of deploying it, of positioning the assets, because one of the most expensive things in a hospital is nurses' time. And when nurses spend all of their time walking between rooms, getting equipment and supplies, it's time that they're spending that is not contributing to the health of patients. And it's a cost to the hospital because they need more staff. So we can use sensors for a lot of different things. It's not purely machine-driven. And that's some of that observational data. Then there's the declarative data. Another thing we don't do well, it's mostly text. We're talking about things, whether it's social media or online text or document repositories, your own doing patent research. In the pharmaceutical field, patent mining has become a big capability. The problem with it is that when you mine that, you have to publish these patents yourself, and so everybody's getting to see everybody else's research. So they're starting to break up academic and medical research that is patentable, particularly in the pharmaceutical industry, into multiple patents in order to hide what they're doing with drug research. Which, all of this sort of changes practices and it changes things. Now, when you look at all of the information you can extract out, there is the kind of text things, just looking at words and word associations. You might think that's not that valuable, but if you sell a brand to consumers or to businesses, one of the things you can look at is what words people associate with your brand. And I did this a few years ago, and it was very interesting working with the company because the words that were associated with their brand were also some of the same words for a product category with a competitor's brand. But then there were words that were very unique to this vendor or that vendor. And when you saw those things, you could actually see ways of using words that people associate with yourself or your competitor's brands to change subtly your marketing messages. And when you do that, you can begin to play games with ways that you market that have never been played before, and it changes how effective your marketing is. There are things you can automatically extract related to topics, what people talk about, all of these things, people, places, locations, product names, can be extracted out of online text. Sentiment, tone, and opinion, these are very, very, very difficult. There's a lot of push for social media today and monitoring social media or monitoring emails or things like that for sentiment and opinion. But it's still extraordinarily difficult, and in terms of its overall effectiveness, pretty weak. But we're being sold on this in the big data world just because of the rise of the internet. Now that's not saying that it's worthless, it's just much harder than we're being led to believe. Now my first experience doing that was mining the opinions and reviews of products online. So this was 2004 to 2005, it's almost 10 years ago now. So this is ahead of having the technology in place today, which makes it an order of magnitude cheaper to do. And what we did is we mined professional reviews. So you look at automotive reviews and you read the various car magazines and you read reviews of the cars. Now then, you go to various car enthusiast sites where there are discussion forums, or now today we have Twitter, and we have Facebook, and we have LinkedIn and Google+. People share their opinions or their reviews, and so you have professional reviews and you have amateur reviews. And so we were able to start comparing, what do the professionals say, what do the amateurs say? What are the amateurs saying is important or not important? When you read reviews and you see the same features being complained about, perhaps you change your product engineering or the design of a feature in a product so that you can introduce things that you hadn't thought about in the design process. And in the case of certain things with long lead times like consumer electronics design or automotive design, those aspects, the more you learn about them, the quicker you can change your processes ahead of your competitors. And so we did some of that in order to find out what people cared about. And I've done the same thing in travel industry for different purposes with hotel reviews. The challenge with hotel reviews online, like if you used Booking.com to stay in this hotel, or if you used any of the hotel websites, you'll find that they all have reviews, and many of them publish and share reviews. But there are also smaller hotel chains or large hotel chains who hire marketers who secretly go out behind the scenes and write fake reviews using fake accounts. And in some cases, it's estimated that up to 40% of the reviews on some travel sites are fake. So you can't just mine the reviews and look at them and take those ratings and sentiment of reviews as truth. You actually have other analytics that people have developed that can assess the text and through various very interesting language analysis figure out that the same person has written 23 reviews on this one website, on the same company, under different accounts. And so you can use these sorts of text analytics to not only buy your research on, if you're a hotel, from some third party who does all of that work, because as I said, it's difficult. The second thing you can do is bring all of that data in-house and have your own people apply the truth metrics to it to see how much of this stuff is fake. So your competitor is making decisions or marketing decisions or service decisions based on the input that is largely fake reviews, while you're doing it based on the real thing because you've thrown out all the fake reviews. So it's interesting to see how all of these things are happening. Now this is all new stuff. These are new analytics, and this is not just counting and summing transactions. In the 1980s, that was what BI did. In the 1980s, it was new. We had point of sale systems which could finally scan UPC codes and capture every transaction. And that was very different because prior to this in retail, what we did is bought Nielsen or IRI or some other big data syndicators market survey statistics. I was a CTO and a CIO at data syndicators, and we build through very small samples market pictures. But it's not every single detail. It's a good picture unless you have a niche product or a small geographic market. When you have this, the numbers can be off by up to 30%, which is enough to make or break, for example, a product launch in the consumer packaged goods world. So when we had scanner data as retailers or as packaged goods companies, suddenly we could change all of these processes. So the new information allowed us insight into our own operations, but it also allowed us to look at things in different ways, which change processes. And over the last 25 years, we've done all of these things. We've exploited new information sources and applied them to business problems, which changed the process of the business, which led to the need for new information, and the feedback cycle continues. And that's where we were in the 80s, and that's where we're going. And all of this is driven, as I mentioned earlier, based on commodity cycles. When you're in the early stages, the 1980s, business intelligence, looking at novel new stuff, the technology is expensive, it takes a great deal of expertise for your company to implement it. It's novel, so you don't have best practices in this world. In this world, you have to experiment. You have to build proof of concepts. You have to find high-value problems that you're dealing with today or new strategies and then attempt to apply the technology. So this is all about innovation and new practices and experimentation. Once the technology becomes good enough and you get from the innovator to the early adopter stage, if you're familiar with Everett Rogers' theories from the 60s about innovation cycles and how innovations are spread, you cross this boundary into the innovation from early adopters into the early mainstream, into the midpoint of the mainstream, into the late mainstream. This is where technologies mature. We went through this in the 90s with business intelligence and the early versions of data mining and analytics. During that period, practices become a little more normal. We start to optimize. Here we spend a lot of money to figure things out. Here we start to worry about the efficiency as well as the effectiveness. And we begin to constrain choices. Instead of building a lot of things ourselves, we start to look for products to fill certain pieces, and then we engineer around them. And the vendors start to spend a lot of money in this phase, perfecting products, building the features. There's enough customers that they're building the features that we need as business people. Now, once things become common, become a commodity, that there's a lot of usage, it's no longer a competitive differentiator because everybody's got it. The goal of a software company like an SAP or an IBM is to look at your best practices and how you use technology, take that back to their headquarters, build it into their product, and sell it to everybody else. And so it's hard to always stay ahead of people, which is why you see people who did really wonderfully in these phases of a market start to do terribly in this phase of the market. Companies come and companies go because of it. Now, as consumers of technology, this is where we live. In a mature market. Best practices, because there's very little value in trying to differentiate your accounts payable process or your general ledger. There's very little to be had in terms of the value versus how much money you have to spend to get that value. So your focus is on cost minimization, best practices, and you start to put a lot of procurement policies in place to make that efficient and effective. Most IT focuses on cost of acquisition and capital costs. And so we go through these processes, and you're down in Six Sigma, total quality management, and these sorts of methodologies from a business perspective there. And here you're talking about agile and open source and open competition and transparency. Now, what will happen eventually is that somebody will come up with a new process, a new technology, new way of using information, and the rejuvenation will start. And that's where we are today with a lot of big data. And where we had trouble with the existing things we apply to business today are the sheer time to get information I mean, when I was a BI director, I was a BI director at a multinational corporation for about 4 years. My biggest problem was the business units would come to me and say, we want to do a partnership with this company. We need this information, and we need to build the data extracts from these systems so that we can see how we're doing. And I would tell them it will take us 3 months. And then they would say, this has a 6-week timeline, and we want to do that because if it's not worthwhile, we're going to cancel the partnership. Why invest more in a not working partnership? So the BI infrastructure couldn't support the speed with which the business was executing. And that time to deliver is changing now because they didn't need good, to-the-penny, perfect financial transactions. They needed good directional information to guide that line of business. And so there's a concept of good enough which does not apply in the BI world. Everybody in the BI world thinks of perfect information and single version of the truth. And so looking at that and looking at the speed to deliver and the speed to use information inside the organization. Now there were some things we would only process once a week. When you process them once a week and people need to make daily changes, you've got a mismatch. And that's where a lot of IT departments today are. And then of course there's all of the new data, better ways to support people. And really, in terms of the technology platforms, cost and ability to deliver analytics and the costs of growth of storing data. It's cheap to store data in something like a Hadoop cluster, these new technologies. It's expensive to store that in Oracle. It's an order of magnitude to 2 orders of magnitude cheaper, but you sacrifice usability of information on one side for cost on the other, and so we have to make some balances as IT executives related to that. Now that takes us to where we are today with big data, which is hype. There is an enormous amount of hype. And the reality of a lot of the big data technology today is that there's a lot more talking about the use than there is actual use. If you tally up the 3 big commercial suppliers of Hadoop, which is one of the big sort of poster children for big data technology, you will find that there are less than 350 paying customers to those companies. Now there are a lot of people using open source who have custom built it themselves, but they tend to fall more into the startup market than into the conventional, traditional IT market. And so we have this situation today where everybody's talking about it, but not that many people are actually doing it. Most of the work is still experimentation in understanding how it can be used and applied in a particular industry. And one of the problems with big data as a name is that it focuses on bigness, and bigness is really not the problem. Teradata shipped the first terabyte data warehouse in 1986. That was a long time ago. And if you look at a graph of sort of the largest commercial as opposed to governmental databases, there is a technology split we've seen. First, we have the Oracle, IBM, SQL Server, DB2, these sorts of databases, which have tracked well into the tens to even at sometimes hundreds of terabyte scale. But this is the performance trajectory we're seeing. This is the performance trajectory of the parallel databases, the newer entrants like the Teradatas and Netezza, which IBM bought, these sorts of parallel database products, into the petabytes. The largest one that I know of for Teradata, I think, is 43 petabytes of data. Now, 99.99% of businesses do not have that much data. So there's a great deal of performance to be had here before we have to jump into the non-database technologies. So bigness with conventional workloads is not there. And the thing is, the processing side of that is what's more important. And when we look at that, we come to cloud computing. And really the benefits of cloud are to think about it as a utility. Think about it like electricity. Don't think about it as buying servers and having an IT department. A utility company does all that for you. And over the next decade, we will see the gradual shift of data centers to third parties where we simply use the performance or the storage as a utility service. And the nice thing is that you pay for the resources you use as you use them, and you get a bill at the end of the month. Now, that changes our whole financial instrumentation in IT. And one of my problems, if I were back in IT today, would be trying to figure out what's going to be capital versus what's going to be expense, because when you have a utility, it's all expensed. And so you're going to change the capital expense structures of IT. And an interesting thing about utilities is that they're elastic. If you turn on all the lights in your home and turn the air conditioning on, you use a lot of electricity. Change the thermostat, turn off some of the lights, you use less electricity. You can do that with computing in certain contexts today, particularly around analytics. And the other thing is that the speed to acquire. If you come to me with a new line of business project and it's going to take X amount of data and all of these other things, I have to buy more software, I have to buy more services, I have to provision, which means I need to go to IBM and buy some new servers, and that process is going to take 6 weeks on the inside. Most likely it's 2 to 3 months for most organizations if it's a sizable purchase. With these types of things, you can now acquire them on an expense basis very, very rapidly. It can take a day or two to set up and provision your environment, as opposed to a month or two. And that means that you can do a lot more experimentation in small projects very quickly, and if they're not worthwhile, you can throw them away. And when you're doing things with analytics, this idea of elastic computing, the idea to scale up resources as you use them, but also to shrink them down when you're not using them. Today, you buy IT by spending a lot of money for the absolute maximum capacity you will need. And then for the first half of the year, you might use 50% of it, and by the end of the year, you're using all of it, and the next year you go and you buy more resources. Well, that whole cycle and planning structure changes when you don't need to do things that way. And so you get speed out of your IT department. And storage has gone the same way as computing. And so you look at the cost buying from EMC versus buying just basic disk drives. There's a huge spread of costs now for the same amount of storage. And you can now apply, say, Hadoop technology to archive much of this data instead of keeping it all in your Oracle or Teradata database, which saves you enormous sums of money. And one key concept here that I think is overlooked very often is that if you have some analytic work to do, say you're doing some logistics work and you're optimizing product distributions or logistics supply chains, you have 10 units of work. Well, you can make a choice. If you don't need it constantly, if your process only changes where you position product once a week, well, one server for 10 units of time, which is the way IT works today. I have a server, I install SaaS on it, I run my models, I update them once a week. In the cloud environment, you can also do this. You can use 10 servers and 1 unit of time. The cost is the same, whether it's 1 server and 10 units of time or 10 servers and 1 unit of time. So if your goal is to get something done very quickly, you can do this. If your goal is something in between, you can do this, and you can balance these things, which means time becomes flexible, whereas today, time is a fixed thing with processing. And that's a huge benefit, and that's part of the whole elastic cloud computing and analytics use case, because you cannot do that with conventional IT. And so we're in this stage today, we're in the middle stage of the market. We're actually way down here with business analytics and big data technologies. Now, how is it applied? Where does the value come from? Most of the value in big data, not all of it, but most of it comes from the analytic use cases. And there are these different things you can do. People like to lump it in, but in reality, there's using historical data to predict activities, which the financial markets have tried to do a lot of. But your models are always incomplete, and therefore they tend to blow up every 2 to 3 years. Now, there's also estimation and forecasting. Description is interesting because it's one we haven't emphasized in the past, but we're starting to now. Understanding the relationships and being able to simulate and predict what's going to happen based on causal models. When you have a causal model, you have a much more powerful model than a predictive model, because prediction's based on the past, and if a market changes, a sector crashes, supplies go down in some respect, there's a hurricane. Any of those things happen to disrupt the process, your predictive models fail. If you have models that are built on simulation, you have causal understanding that when this happens, this is going to change. And the causal models allow you to anticipate the effect of your own actions. When you change your business process, you have to update your predictive models, but you have no history because you've just changed your process. And so you're essentially starting from scratch. And so some of these techniques, which we're starting to use today, are a lot more powerful than the predictive techniques. I don't really have the time to go over specific use cases, but I'm happy to talk about them at the break. The key point of some of these things is that if you start to look at one other aspect, individuals as opposed to collections. Business intelligence is about individual things. Big data is about getting at each thing. So if we look at customers, you can take any brand. I don't care if you are Caterpillar or Schlumberger and you're selling industrial equipment for construction or for oil exploration, or you're making Coca-Cola. A very small percentage of your customers make up the bulk of the revenue for that product. And there's always going to be a very steep distribution. In the case of Coca-Cola, 12% of the customers account for 80% of the revenue. And you know, when you look at things like this, the only way to do this is to actually take every single customer and all of their transactions and count them individually. In the old way of doing things, you would just count up the revenue and ignore the individuals. And where this becomes important is that you start looking at the percent of shoppers versus these things. And I've done some retail analysis like this. What you discover is that very tiny percentages, 0.7% of Heineken beer's premium light brand contributes to 80% of the revenue or the total sales volume for that thing. If you're going to launch a new product or do something like a line extension, you really want to know what people are going to do this, and you'll find out that the mass market is actually a myth. There is no mass market. There are lots of micro-segmentations of it. And when you're doing things like launching new products or understanding customer behavior, the historical way to do marketing around these things was to look at the total customer base. In reality, you want to look at certain key aspects of the customer base at an individual basis, and so you're going beyond the transactions. There's been a lot of discussion about social media and social network analysis, and we'll hear more about that today, so I'm not going to go into it, except to say that there are now many contexts that we can learn from. In the consumer and the business-to-business, because every business buyer is an individual, you see that there are different places. In banking, you've got ATMs, and you've got online banking, and you've got the branches themselves, and you've got the telephone support. These things are all automated today. When I managed a call center, we brought in call management systems, we brought in the website, we brought in every single source of information, and all of that was observations about customer behavior. And that's what you build your models on. I'm not going to go through this example, I can talk about it at the break, but really you're looking at individual paths to see when customers defect. And when you see this, in the data warehousing and business intelligence world that we've had in the past, every single one of these was a channel and they were a vertical silo. The call center was here, the website was here, surveys and marketing were over here, the transactions were over here. And so when you look at it, you have this green field of data, and the strategies today have been all about finding the pony in the field. And that's really the wrong way to think about it. The right way to think about it is that you have specific goals or things that you want to accomplish in the business, and you work into the analytics, because analytics are very goal-oriented. They're not magic, here's a field, go out and find something in that field of data. I think the decision support stuff I was not going to talk about, but when we look at decisions and we try to classify them, there are these very coarse-grained things that people have talked about. The important aspect is that operational decision-making and transaction processing, the scope of control your line workers have is within a process. The middle management of the organization can actually resolve the exceptions. If you can't escalate something or you can't fix it inside of SAP because it doesn't work that way, a manager has to get involved to deal with that exception. And there are points where the line management or the middle management can't deal with it, and as an executive you make these decisions, but what you're really making a decision about here is changing an individual process. Here you're working within a process. Up here, you're trying to figure out what configurations of processes work best in your business. Strategically, what direction you want to go, and which of these you want to invest in, and which of these you want to get rid of. And so the information that we've had to date has really been down in here, and now we're talking about supporting things up in there. And when you look at it, the nature of these decisions, the times, the types, the fact that this is very narrow, almost programmable decisions versus very flexible, non-repeated decisions at the high level. And what we're really seeing then is this is seeking adaptation and innovation and change. Everything from tactical into operational is really about managing the efficiencies and operation of the business, which is about stability. And these two things are always in tension in the organization. And to date, most of our business intelligence has been focused on this. And now we're seeing the technologies and software capabilities that focus on that. And so that's where you see the difference between these two sets of technologies, and I won't go through that except to say that in the world, when we look at what we've got, we have assumptions. And the assumptions of the business intelligence space were about order and simple cause and effect. Whereas when you start to look at the disordered states, you can't just gather data, categorize it, and program a response. You have to analyze the information and work out what you're going to do. And in executive decision making, a lot of it is built around ambiguity and uncertainty and good enough data. And that's where we get into these things where we're talking about testing and trying things out, seeing what happens and then adapting your responses. And this is really agility and adaptation. And that's where our technologies are going to support them. And so the state of the market today for technologies is still very early. One of the things I'll tell you is that it's supply side. Vendors are driving it more than customers are pulling it. There's an excess of software companies pushing this on us. And it's because venture capitalists have tried to fund tech companies to accelerate adoption in the market. But the reality is that we have to change our IT, we have to learn new skills in the IT organization, we have to learn how and when to apply these things to business problems, and that slows down our adoption. And no amount of venture capital going into the startup world is going to change that. And so there is a crash coming in the big data market. These startups are going to start running out of money this year, and you're going to see the deflation of hype. But the technologies are real and the applications are real. It's just that we can't take them in as fast as they are being produced today. And that's because we need to develop new skills. And just like the 1980s scenario that I showed, we have new things to learn about how and where and why we apply these. And so today you'll see that most of the big data market is built around startups and companies that did not have a lot of IT infrastructure. And that leads us to the conclusion, which is that the future will be just like the present and the past, only more expensive. And so with that, it's break time. Panos is giving me the timeout signal.
I know that you would like to talk all day long because you have too many things to say. I'm sorry interrupting both of you, Ahmed and Mark, but we have to close the first panel with Dmitry Yefimov.
That's right.
Dmitry got his PhD in mathematics in 2007 from Moscow State University in Russia. Currently, he is an assistant professor in American University of Saran. His main area of interest is machine learning and big data research. Dmitry Yefimov is a winner of several data mining competitions, such as the biological response, pan-social prediction, and Kurtoz's actions. Dmitry?
Okay, great. Good morning, everybody. I'm glad to greet you here, and I'm glad to give a talk here. So, in my talk, I will tell about just one case study, how you can use data mining and machine learning in decision making for business. So, what is this? This is Golden Goose. What is Golden Goose? Golden Goose brings golden eggs, and it will be our purpose. So suppose, let's take a simple example. Every company has a miles program, and we have 2 passengers who enrolled in this program. The question is, how can we help the CRM manager to predict if the first user will be economy flyer, or the second user will be silver flyer. So if we define, for example, that this it will be business flyer, it will be silver user, then we can give perks, we can give retention actions, we can give different benefits for this before he reach this state. So basically our purpose is to find some algorithm, golden goose detector, which can help us to predict if user will become silver or gold user or next. In this case, we will give all these benefits to this user. Okay, how it's done by now? Airline take just previous information about miles, about current status of miles, and it makes just, as you can see, just linear extrapolation. So pretty simple model, and it doesn't count very important information like age of passenger, or origin of passenger, or different types of flights, or what is the most frequent flight for this passenger. So this is very important information which is not used here. Okay, basically our model, we call it DS model, is a mathematical model. So what we've done? We've done actually a very simple thing. For each user we created, we took some period, for example we can take 3 months, and we collect all information about users. So miles, reached miles, and so on, like age and origin and so on. After this, we run our model and we predict if this user becomes silver user during next period. So we call it DS because D is our observation period and S is our prediction period. We can take actually different. We can take different period for. We can take different D and S. So it works actually, and the advantage of this method that we can consider everything, whatever you want. It can be categorical things like country of origin and so on, or it can be some quantitative things. So, example, how can we use this model? We can use this model in a very simple way. Suppose that we have flight from from Abu Dhabi to London, and we have 5 available business seats, in business class. And this is example of result. This is a real example of course, with not real names, but with real numbers of output of our model. And what can we do? For example, we can sort our probabilities for if user becomes silver or not. And we can give this benefit before the user will become silver or not. So for example, we can give them these 5 available seats in business class. Because in this case, this user will be happy. This is example. Actually, after this, I just took some screenshots of our results, real results in Excel. And there is example of the first model. You can see that accuracy is pretty high. If you look at the second column, we can see that our error is just 37 users out of 1,346. So it's less than 3%. So it means that we make a mistake only in 3% cases. So it means that we almost never make error for users. If we give them some benefit, then for sure he will become silver in the future. This is example of our sorting, and you see the top of users, they really become silver. So you see that probability is very high. Then for sure he will become silver, because there are some errors. There is example when it's very difficult to define if user becomes silver using just miles or by hand, for example. So this is just 2 examples which our model gives. Now, if you take not optimized model, this was optimized model when we took D equals 3 months and S equals 1 month. So we took period 3 months for each user. This is another model, not optimized, when we took just 2 weeks of activity for each user. And we predicted it for 3 months. So S much bigger than D in this case. Of course, accuracy is less, but anyway, it's still appropriate. Only 8 out of 70, only 8 users we didn't predict correctly. So there is example of initial model which all airline company uses now. So this is just sorting by miles, and you see that it's not very accurate. It's not accurate at all. And this is our result of our model for not optimized case. So you see that accuracy is pretty high. And thinking that in the air company you don't need, as I told you, don't need to predict if all users become zero or not. I mean, we don't need to find it. We have to just find users, probably 50% of users to give them some benefit. So. If you look at another table, which is ordered by accumulated miles, so it's also not very good. And actually, this model, we think about this as for a company as model. So, any questions to this? This, I think, this is a very good example of real application of mathematics and machine learning algorithm to business, and I think so. It's really working now. Thank you very much.
Actually, I would like to ask Dimitri, Ahmed, and Mark to come to the panel to have the Q&A session.